Finally, I'm ready to launch. Now all I have to do is start my Express server. Hang on, what is that? Oh well, I'll just sudo it.
This is an intervention. You are doing it wrong. You should be using NGINX.
Okay, what is NGINX? Ah, I see. Welcome to this crash course on NGINX. Over the course of the next 30 minutes, we will go over all of the basic applications that you might use NGINX for in your own applications and management of your web servers. That includes serving static content, using NGINX to manage your SSL encryption, to set up a reverse proxy so that we can receive HTTP requests on one port and forward them to another, and to act as a load balancer so that we can equally distribute load among many different web servers. So as always, grab a drink and let's start coding. For the course of this video, I've prepared a little GitHub repository. And what this repository contains is 3 different directories for 3 different use cases, which we'll be using NGINX for. So make sure you go to GitHub and clone this repository before moving on, so you can follow along. Just to give you a brief overview on what's going on in these directories, let's open up the code editor. You will see a directory called website template. And in the website template directory, it's really all there is. There are a lot of static files which present a template website, which I took from templatemo.com, just so that we have something nice to look at. The only thing I changed is that there is a custom JS file. And what this does is it will query our URL to display the data that we get from 2 of our endpoints. One will be greeting and one will be service. Aside from that, there is the basic API directory. And this simply contains an Express web server, which exposes 2 endpoints. One is the API greeting endpoint, which will immediately return either with a hello and then the query parameter called name in the response, or simply a hello world, which will be contained inside this object with a greeting key. We also have a service API, and what this does is it uses the HTTP proxy middleware to forward this request directly to another endpoint of another web server, which is actually contained inside basic service. And what basic service does, it is also just an Express app serving one endpoint called hello and a fallback endpoint in case we get any errors, so it's easier to debug. And this hello endpoint simply responds with a hello message displaying the internal port. Because the way that we'll be using this basic service is, if you check out the package.json, is that we will be running concurrently 2 instances of the service, one on port 4000 and one on port 4001. And what this will enable us to do is it will simulate a microservice environment potentially, where you have an API, which is represented by our basic API, and it is forwarding requests to different instances of a potentially long-running process or a highly computational expensive process that might be running on a different thread on the same server, or potentially even entirely different servers within your virtual private cloud. So that's essentially all there is to it. If you're running this on your own server, make sure to read the README so that you know how to adjust this code so that it will work properly for your URLs. In preparation for this video, I've already set up a little server using Lightsail. If you don't have a server available to you or you don't know how to get started, make sure you check out my previous video first, which is going up at the same point in time as this video is, and then return to this video to continue on. So what this is essentially it's running an EC2 instance using Ubuntu version 20. We have a static IP address assigned to it, which is publicly available. We have the HTTP and HTTPS ports available, so incoming traffic can actually reach the instance. And we also have domain names configured with NGINX pointing to the public IPv4 address and the IPv6 address. These domain names assignments are essentially just the A and quadruple A records on your DNS entries. So if you don't have an interface like this because you're using a different hosting provider, you should still be able to set up those records. Assigning domain names is super important because we will be using those to create our SSL certificates so that all traffic to our website and our web server is encrypted. Now with that out of the way, let's go to our server where I'm already SSH'd in and install NGINX. To make sure that you don't already have NGINX installed, just run the command sudo nginx -t, for example. And what that will do is if you already have NGINX installed, it will check and validate your config setup. Now I don't have it installed, so it doesn't recognize the command nginx. Now what I'll be doing is I will be following along with the official installation instructions from nginx.org. Again, link to that in the description below. So first of all, we need to install the dependencies. So let's just copy paste that in here. Next up, let's get the signing key. And afterwards, we can perform a dry run and we can check the signing key to make sure that it matches the official version, which in this case ends on BF62. So that should be fine. Now that we have verified the fingerprint, we can set up our local app repository. So just copy that part. We will be using the stable version, not the mainline one. And we will be pinning that repository as well. So let's just copy paste that command. You can basically ignore all of the debug logs here. You will see that everything has worked out by finally running sudo apt update and then sudo apt install NGINX. What we've basically done is we have modified our repositories in a way that we won't use the default Ubuntu repositories, but instead we have defined the official one that we want to fetch this specific installation from. All right, let's clear the screen and run sudo nginx-t again. And we see that nginx has been successfully installed. Now, nginx isn't running by default. So if you open up your web browser and you navigate to your website, you will see that the website still can't be reached. So we have to start nginx. Now, technically there is the nginx start command, but we will not be using that one. Instead, what we will be using is the systemctl tool. So to start that, just run sudo systemctl start nginx. And if you don't get an error message, then everything should be fine. You can check the status by running sudo systemctl status. And we can see that it is active and running. And this enabled flag up here means that whenever your server restarts, systemctl will take care of restarting the servers. So you don't need to worry about the server crashing and restarting and that causing any issues. Cool, so just hit Q to exit out of that. Let's clear the screen and open up our web browser again and refresh. Now, if you still get a "this site can't be reached" error message, that might be because your browser is defaulting to HTTPS instead of HTTP. Now, HTTPS, of course, isn't supported yet, and we aren't even listening on that port. We're only listening on port 80. So just remove the S from the HTTP, and you will get your welcome to NGINX greeting. Now, this is great because we have confirmation that our NGINX web service is running. But what is actually happening under the hood? To figure that out, let's go back to our terminal and navigate to /etc/nginx. And this is the directory where all of your nginx configuration files will exist. If you just run ls, you will see the nginx configuration file. So let's just cat that real quick. Now, what you will see if you scroll up a little bit is a few definitions, for example, under what user this process will be running, where the error logs will be stored and the level which should be logged. And down here you see the HTTP context. Now the way nginx configuration files work is you usually have some sort of context block, like the HTTP block here. And inside the block you have individual directives. For example, down here you have the log format directive, which specifies what your logs should look like. You also have the access log directive down here, which specifies where those logs shall be stored. Now for us, the most interesting directive is the include directive, because in here we don't see a lot in regards to what sort of content is actually being served when we enter our URL. And in this include directive, you can see that from the path etc nginx, which is where we are already at, there's this confd directory. And inside that, they are including any file that matches essentially any string and then has the .conf extension. So let's navigate into that directory. Simply by going cd into, actually let me clear the screen, and then cd into confd. Now if you run ls here, you will see that there's a singular configuration file. Let's open that one up by running sudo nano default.conf. The sudo is important because that file is a protected file. So if you just try to open it via nano, you won't be able to save any of your changes. Now an nginx configuration file can seem quite daunting at first, but we'll break it down step by step, so it should be quite easy. At the moment, all nginx is doing is it's serving static content. It's serving a static HTML file with a bit of CSS. And this is achieved by specifying a web server context. Now you see here that there is this server context opened up, and there's only one server context in this entire file if you scroll down. Now, a singular configuration file can contain multiple servers, and you can and you probably will be running multiple web servers within your singular nginx instance. Now, in our case, what we're doing is the server is listening on port 80. Though this is primarily for an IPv4 configuration. Since we also want to serve IPv6 requests directly, we can also specify the typical format for an IPv6 address, by using the square brackets and the colons and then specifying port 80 again. Next up, we have the server name directive. Now, the server name is actually a list of host names that this server configuration applies to. So localhost is, of course, the default one, which resolves your 127.0.0.1 IP address. We can also append more server names here. Now, in my case, I want to make sure that the nginx.douglas-riser.com is also being served with this web server. Now, this already worked without having specified this because it uses this entire configuration here as the default in case nothing else matches. So now we know how this web server is actually receiving our HTTP request when we open up our URL. But what is it actually serving? To figure that out, we need to go down to the location block down here. The location block specifies what should happen to those incoming requests. In our case, there is a route specified. So it's essentially saying that any request that comes in with this base path should be directed to this local directory. So there's this route path specified to user share nginx/html. Now all of that is a path that is available on disk here. And what it's saying is that if there is no file name specified or no extension specified, then try to search for an index.html or HTML file and reserve that. Now, if you were to, for example, request a URL, let's just add a comment here, /images/cat.png, what would happen is it would resolve to this location because the initial / matches, and then it would try to append the images/cat.png path to this original root path. So it would try to search for this image, and if it doesn't find one, it would return with a 404. And that's essentially all there is to resolving static content. Now, there are some more directives that you can use to rewrite the paths, for example, if you have a different nesting structure. And instead of this simple /, you can also specify more concrete paths. For example, you might want to resolve image paths that start with a / image to an entirely different directory than you would, for example, want to serve your HTML files from. Now, moving on, you can see that there are quite a few comments for different purposes, like what should happen if there is a 404 response. You can serve a specific file, and you can also serve a specific file for certain error codes. And all of that is handled by NGINX, so you don't really need to write any code here. It's a very fail-safe way of making sure that no matter what error your users encounter, for example, if your site is unavailable or currently down for maintenance or updating or whatever, then your users will never be facing a blank page, but you can configure this in a way that they'll be always served a sort of baseline error page, which is pretty neat. Now, if you scroll down further, you will see that there are some pre-configurations for PHP settings, which are all commented out, and we won't be using those today, so that's all good. So let's just exit out of this and save. So now that we have a basic understanding of how serving static files works, let's serve it our own website instead of the default one provided by NGINX. So to do that, I will just navigate back to home and clone the GitHub repository I showed earlier. So let's just copy paste the URL here and run git clone. Now what this will do is we'll create the NGINX tutorial directory. So let's just cd into that. And then we have the website template directory. So let's cd into that as well. And there we can see the index.html file and all of the other static content as well. Now we will be specifying this as the path. So just run pwd to get the entire path printed out and navigate back to your NGINX configuration and open up your configuration file, the default one. Now in here, what we'll simply be doing is we'll be replacing the root path. So just delete all of that, paste your own path in, and make sure you close the line with a semicolon. We don't need to change anything else, so simply press Ctrl X and confirm the save and exit out of that. So of course, anytime we update the configuration, we need to restart our NGINX server. So we can do that by running the sudo systemctl command, systemctl restart NGINX. Of course, what we could also have done is we could have run sudo nginx -t beforehand to make sure that our configuration file is actually proper and without any errors. The reason why you would probably want to do that is if your restart fails because of some bad configuration, then you would of course have downtime for your web server. And if you have ongoing traffic on that, that's probably not a great user experience. So it's usually good practice to run NGINX -t just to validate that your configuration is set up properly before you restart your server. All right, going back to our website, let's just refresh. And we should be served with the template that we specified earlier. So with that, we've already completed chapter 1, which is serving static content from a specific location. There's one thing though that's really bothering me, and that's the not secure flag up here. Now, any professional site nowadays really needs to be SSL encrypted so that you can use the HTTPS protocol to access your website. Now, the great thing about NGINX is it's free and super simple to implement. So to do that, we'll be using certbot. So go back to your terminal. Let's just clear the screen here. And first of all, we need to install some dependencies. And these dependencies are certbot and Python 3 certbot NGINX. Again, the command for that is in the description below or in the README. Now, once the installation is complete, what you can do is you can run the sudo certbot -NGINX -d for domain. And now you have to enter the host name under which your web server will be reached. In my case, that is nginx.douglas-riser.com. You can also add multiple domains here just by adding more -d options at the end. And what that will allow you to do is it will allow you to generate a single certificate, which you can use to encrypt multiple domains, which might be pointing to the same web server, but are then resolved differently by NGINX. So just hit enter and enter your email address here. Agree to the terms and services. I do not want to share my email. And now the challenge is happening. So what happens under the hood here is that it creates an endpoint which is specified by the Electronic Frontier Foundation. And on that endpoint, it is serving a specific key that then this foundation is querying for to see if you actually have ownership over this domain. And as a result, it will afterwards generate your SSL certificate. Now, it's asking us after successfully generating that certificate if we want to redirect all traffic from HTTP to HTTPS, which in our case we want to do. And we're done. It's as easy as that. Now, the very cool thing with certbot is that it also automatically updates our configuration. So if you open up with sudo nano your default configuration file, you can see that it's changed quite a bit. So if you scroll down here, you can see that now the server is listening to port 443 on IPv6 and IPv4 addresses, which previously we were listening to port 80. But the port 80 listening has been removed, which is the typical HTTP port, so without the SSL encryption. And it has added our certificates and some more information that is managed by certbot. So we don't need to worry about that at all. We can also see further down that there's a second server configured, which is listening on port 80. But all it's doing is it's immediately redirecting you to the HTTP version of the same request with the same host and request URI. And this is already one instance where multiple server definitions within a single configuration file make a lot of sense, because then you just have a single place to manage all of that. Now, if you didn't specify your custom server name here, but you just had localhost before that, then the entire certificate generation would still have worked because that endpoint would have been reached from the outside. But then certbot wouldn't have known which configuration file to update, because potentially you could have many configuration files with many different servers. So because we specified the server name here in advance, it was able to do that auto configuration. Now, if you missed that part, don't worry about it at all. You can either just copy paste the config from the example file that I have in the README, or you can just add your server name here, repeat the process, and it will ask you if you want to expand and repeat the entire process. And at the end, it will create those auto configurations for you. So let's exit out of that. And once again, first of all, let me clear the screen. And then rerun our restart command. And again, of course, we could have run nginx -t beforehand. So let's go back to the site and just hit refresh. And you will see that automatically our connection is now secure. And that's how easy SSL certification can be. From this point on, you don't need to worry about any sort of SSL certificates for anything that is served from this hostname. So if you have some more, for example, Express APIs, etc., that you will be still serving from the same host, then those will automatically be SSL encrypted because that's what the NGINX web server does for you. Now that we have a place to serve our static content, what about serving our Express API? We want to serve that in a way that also benefits from our SSL encryption. And ideally, we want to have something like NGINX, our host name, and then /API, and then our endpoints. Now with NGINX, that's only a few lines of configuration that we need to add. First off, let's go back to our server and make sure that our Express API is running. So I will just go back to my home directory and then the NGINX tutorial. And in there, we will go to the basic API. So cd into that and run npm install to install all dependencies. Clear all of that. So there are a lot of ways to keep a process running in the background, even when you're exiting out of a shell. Probably the most preferred method for that is pm2, which is also a node package that can be installed via npm. And it gives you a nice interface to manage all of your processes. To reduce the number of dependencies and to keep things simple, I will use tmux. Tmux comes pre-installed on Ubuntu systems. And what it does is it allows you to create virtual terminal sessions. And these sessions will remain in the background. You can attach and detach them from your current main session. So they will just keep running in the background until they are explicitly killed. So in my case, I'll just run tmux new -s for session and then call this API session. And you will see that it has opened up a little bit of a different view. And in this view, I can run npm run prod, which I defined in my package.json. And what it does, first of all, it will build, and then it will run the API on port 3000. To detach your session, hit Control B. And afterwards, you won't see any changes visually, but afterwards, just hit the key D for detach. And now if you run tmux ls, you will see that you have one session currently running. And now just to test if your API is running, you can run curl 127.0.0.1 3000 /API/greeting, I think. And then we get our response. So we know that the web server is running in the background. So now all we need to do is whenever there is a /API as the beginning part of our URL, then we want to redirect traffic internally to our port 3000, so we don't actually need to expose port 3000 to the external world. So going back to our /etc nginx and then confd, and in there we sudo our default conf again. Now for this purpose, we don't need to start a separate web server. Instead, what we can do is we can go to our location block here and add a new location block. And this will resolve our /API/connections. In order to proxy an incoming command, NGINX has the proxy path directive. And for this proxy path, all you configure is what server is supposed to receive this HTTP request and where is it running. In our case, that web server is running locally, so 127.0.0.1, and it is running on port 3000. Now, in our case, the way our web server is configured is that it expects requests on /API and then /greeting or /API/service. So all of those routes will match this location. And this is important to note, the entire location path will always be proxy to the receiving server. So this /API part, which is part of our location, will not be removed when proxying to another server. You can use a rewrite directive to manipulate that behavior in any way you want, but in our case, let's just keep it simple. So let me delete that line and save the changes. Now this time I definitely want to run the sudo nginx test command. And we can see the test failed. So invalid URL prefix. So let's go back into it. And we forgot the HTTP protocol. So let's add that, store it, and rerun our test. And this time the syntax is okay. So now we should be good to run the restart. So after restarting our server, let's go back to our browser and refresh the site. And you can see that the first request is resolved because what this request does is it contacts our API. We can also just quickly test this in our browser. So copy paste the URL and then /API/greeting. And we can see that the request resolves, and it resolves as an HTTPS request, which we didn't need to handle on our sort of express level at all, which is super neat. So essentially, just by adding these few lines of code, you've already created a reverse proxy, which is really all that this is. It's accepting requests coming in on one port, and it's proxying them to another web server, and then passing the response back. So now you essentially know how you can run one or even multiple APIs from a single physical server instance, which is super cool. Now, another purpose that NGINX is oftentimes used for is for load balancing. What load balancing essentially means is that you have one point where you have a lot of incoming requests, and then those requests are split up to different server instances to handle those requests. You might even have that on the API level itself, or you might have that for more computational intensive processes. So imagine, for example, you have a server instance taking care of a very large AI model, and that server is able to handle a maximum of 4 or 5 requests per second, and you have more than that coming in. Then you would want to spin up multiple instances of that across even multiple physical servers, and then redirect those to whichever server currently has the least amount of work to do. Now that's a very typical use case for load balancer. In our scenario, we don't really have a complex setup like that. Instead, what we have is, if we go back to our code, is that we have our basic API, and in that basic API, we have the /API/service endpoint, and that just proxies it to a specific port and appends the hello path. Now, what we don't want to do is we don't want to run another Express server on this specific port, because what that would mean is we only have one other instance taking care of that. Instead, what we want to have is we want to have an NGINX load balancer operating on that port, and then redistributing those requests to our basic service, which will be running on port 4000 and 4001. And this load balancer itself will be running on port 3333. So let's go back to our terminal, clear out of all that, and go back to our home directory and make sure that we actually start our basic service. So let's go into NGINX tutorial, cd into basic service, run npm install again. Now you can open up a new tmux session by using tmux new s and call this service session. And in here we can run npm run prod. And we can see again that it will compile our TypeScript and then run 2 instances on port 4000 and 4001. Now if you want to stop and restart your node processes, you can switch between your tmux sessions by hitting Ctrl B and afterwards S, and you will see a list of your active sessions that you can just navigate with your arrow keys and then hit enter to enter into that session. Now next up, hit Ctrl B and afterwards D to detach. Clear this. And we can just make sure that this is running on port 4000. So we can just curl 127.0.0.1 and then port 4000 / hello. And we can see that we get the expected response, hello from internal port 4000. And if we do the same for 4001, we will get the response with the port 4001. Nice. So now that the ports are running, let's set up our load balancer. So cd back into etc nginx and then conf. Open up your default configuration again. So sudo nano default conf. And this time we will be adding new server blocks. First up is adding the upstream context. So the upstream context is essentially a collection of servers that you will be able to proxy to from a certain point. So write upstream and then in our case, basic service. Now you can define any name that of your choosing here. Add those curly brackets. And then in that basic service, we can add 2 servers. One server is at 127.0.0.1 and port 4000. And the other one is just cut and paste this twice, is on port 4001. Now that we have assigned these 2 servers to this upstream context, what we need to do is we need to listen to requests that are internally wired to port 3333 and then proxy them to this upstream context. So to do that, let's create a new server. And that server is listening on 3333, semicolon. Oh, and I also forgot the semicolons up here. And then just as a location, we don't have anything specific. We'll be just routing it to the root location, since anything that is contacting this port should be proxied to our server. And then again, we can use the proxy pass directive that we used earlier and just set this to HTTP, because that's the protocol we'll be using, and then the basic service. And add a semicolon at the end. That looks good to me. So we can exit out of that, save, and run sudo nginx to make sure that everything is configured properly. And afterwards, run restart. Going back to our browser, if we now refresh our initial page, we see that the second message also resolves because that's now proxy to our basic service, and we get the response, hello, from internal port 4000. Now, if you refresh this a couple of times, we will see that there's always a different port answering, because by default, the NGINX load balancer is using a round-robin mechanism, where every time it receives a request, it will make sure to give that to a new server instance to make sure that they're equally balanced. You can, with NGINX, also implement sticky sessions so that it will hash the IP address and make sure that the same IP address always gets resolved by the same server. And that is important if your servers are stateful in any way, so that you don't lose any data in between individual connections. And that's really all there is to NGINX. So now you know how to serve static content, you know how to build a reverse proxy, and you know how to implement the load balancer. And you can combine all of these components in any way you like to build out any application and any complex server setup, essentially. Because even though we're always referencing internally running node processes or web servers, you can also reference these across machines that are part of the same internal network. So you might have one machine receiving requests from the internet and then distributing those to other machines running on your network. So in effect, this is the first step in progressing towards microservice management, for example. Now, of course, just NGINX is very bare bones for that, and you would probably want to add on things like Kubernetes, etc., in a more complex environment. But this already allows you to get started with a fairly simple setup with the minimal configuration and at a minimal amount of time. Now, that's already all there is to it. Now, you're free to explore the NGINX documentation on your own now that you have a very good understanding of the basic concepts. Or if you feel that you want to host your own application and you don't want to use a standard REST API, but instead you want to, for example, implement a TRPC API via Express, then I have a video on that and make sure to check that out. I think you'll find it very interesting. I really appreciate you sticking around until the end. See you next time. And as always, happy coding.